Hello. So we are going to start chapter 8 uh, this week. So chapter 8 is about estimation, which is the most important chapter in this course. So I expect to spend like 3 lectures, 1.5 week on this chapter. So before starting the main estimation theory, I'd like to set up and review the basic concepts in statistics, and we will review how they are connected to each other. So let me start from the very fundamental concepts in statistics: the population and the sample. So the population is the set of all objects of interest. For example, all voters in the presidential election. And the sample, on the other hand, is the set of observed objects from the population. For example, like voters who responded to a survey. So, and earlier in this course, in chapter 1 and several times, roughly I explained the population is when you repeat the experiment for an infinite number of times, but the sample is the outcome when you repeat the experiment for a finite number of times. That's just a way to understand them, and that's not wrong. And basically, still that's if you prefer that interpretation, that is also fine. The basic idea is that the population is everything we would like to know. So if we know the population, then we know everything. But that is not possible. Instead, we observe a small part of the population, and that is the sample. So sample, graphically, visually illustrating, the sample is just a part of the population, and most of the population are not observed, but a small sample, the sample is observed. Of course, the larger the sample is, the better and the more accurate your inference would be. So distinction between the population and sample is important because when you estimate something, you need to set what you would like to estimate, and you have to think about how you are going to estimate. So population is related to what you would like to estimate, the target, and the sample is related to how you'd estimate, because the sample is the available tools for you. So the distinction is particularly important here. And in the previous chapter, we learned the random sampling. That is how the sample is generated from the population. So random sampling is taking a subset from the population at random. At random implies two assumptions, which we will take as granted in this course. So random sampling is literally randomly choosing some observations from the population, and that is a theoretical assumption. A theoretical, and we studied what kind of results we can obtain under those assumptions. And what we're going to do in this chapter and in the later chapters is going the other way. What we hope to do is to infer about the population using the sample. So we observe the sample, but we do not know about the population. But we would like to know the population. Therefore, we will go the other way, from sample to population. That is statistical inference. So we studied the random sampling first because we have to go the other way in inference. So statistical inference is to make statements or make inference about the population based on the sample. So for example, if you think about the, say, population is all voters in the presidential election, and the sample is political survey or political poll observed, like say respondents, and then the statistical inference is to guess who is going to win the election based on the surveys, based on political surveys. That is the big picture of what we are doing here, right? So and here, so based on this, so now if you understand these two, we can define additional terms. Now in inference, in estimation and in statistical inference, parameter refers to any numerical measure about the population. So in chapter 5 and 6, the parameters are used as a different term, different meaning, had a different meaning. So in binomial distribution and in normal distribution, parameters are a few numbers that fully summarize the information in the distribution, right? But now we are going to use the term parameter in a slightly different way. So now we will think the parameter as any measure about the population. Anything about the population is a parameter now in inference. So it can be a mean or a median or the variance probability, whatever. Like, so anything you can obtain only when you know the population will be referred to as the parameter. So simply speaking, this is what you want to know, and you need infinite observations to compute the parameter. So the parameter will be our target. It is a description about the population. On the other hand, statistic is the counterpart of the parameter, sample counterpart of the parameter. So parameter is for the population, then statistic is for the sample. So statistic is any measure about the sample, calculated from the sample. So if you have, like say, 100 observations, still you can calculate the mean, the median, the variance, the probability, whatever. So you can calculate still a lot of things, even if you have a limited number of observations. They are statistics. But you have to understand that. So statistic is what you can calculate from the sample. So this is the tool, or the parameter is what you want to estimate. Then how are you going to estimate that? You are going to use some statistic to guess the parameter. So statistic will be your weapon, your tool to answer the question, right? And so important properties, characteristics of them are, the parameters are usually unknown. So we are studying statistical inference because we do not know the population. If you know the population, then you don't need statistics. You only need a supercomputer. But so we are going to assume that a parameter is unknown, but we want to know that, right? That's the basic setup for statistical inference, and the parameter is the target of statistical inference. In general, for general theory, well, usually a parameter is denoted as theta. Theta is a Greek letter which is usually reserved for the parameter of interest that is going to be estimated. So anyway, it's a notation. And on the other hand, statistic, so parameter was unknown, but what we want to know. But the statistic is known because you can calculate that from the sample, and sample is available. So from the observed sample, you can calculate the statistic. So it is available. It is known. However, it is random, which means it can have some error. It may be different from the parameter. Statistic is random because it follows the sampling distribution. That's what we learned in chapter 7. So remember, statistic is calculated from a sample. So if you resample, if you random sample again, then, and if you recalculate the same statistic, the result may be different. So in that sense, a statistic is random, which means it has errors, random errors, right? So this is the answer, the product, the result of a statistical inference. We are going to estimate theta by a statistic, which is usually denoted as theta hat. We put hat on top of the parameter. So usually hat is the counterpart, the statistic counterpart of the parameter, or usually the estimator for the parameter. So here are some, this is two different methods we are going to learn in this course. There are two main methods are estimation and hypothesis testing. So estimation is in chapter 8, and hypothesis testing will be covered in chapters 9 and 10. Their major difference is the type. So the difference is in the type of question they are answering. So estimation is to answer an open question like, what is the percentage of voters supporting candidate A? Or what is the mean gas price in New York City, right? So it's open question. You can say 1%, 2%. You can use any number to answer those questions. So it's an open question. But hypothesis testing is to answer a closed question, yes or no question. Like, so for example, do you think more than 50% of voters support a candidate? Or do you think if the mean gas price in New York City is lower than $3 per gallon or not? So hypothesis testing is called hypothesis testing because you have a hypothesis. For example, in these examples, you believe that candidate A, more than 50% of voters support candidate A. That is the given hypothesis, and you are testing if it's correct or false. Similarly, you believe that the mean gas price in New York City is lower than $3, and now you are testing if that hypothesis is true or not using the data. These two, the estimation and hypothesis testing, are both useful and widely used, and they are closely related, right? But the techniques and detailed the terms used and the details are slightly different. So we will spend a lot of time on learning them. So let me go deeper into those examples just to help you better understand the terms. So think about presidential election. Election prediction is a good example of statistical inference, right? Last year, there was a presidential election, and there were a lot of estimations and predictions, a lot of polls, surveys, and they are basically doing statistical inference. They gave you like estimated percentages or votes there the each candidate will get, like that. So in that example, the population is all voters, right? Of course, there are details about the rules, but let's simplify. Just all vote. If you know all votes, if all votes are open, then you know the truth. So the population is all votes, but you cannot survey all voters. So what's only available to you is the sample, which is survey respondents, which is a subset of voters. And then what we are interested in is parameter which is defined as the probability of voters supporting candidate A, simply, right? So how many votes, how many seats candidate A can get, right? So probability, this is about all votes about the population, so it is a parameter. But to estimate that, so this is your target, you'd like to predict this parameter, estimate this parameter. So how can you estimate that? You have to use something calculated from the data, which is typically the probability of respondents, survey respondents supporting candidate A, right? So this is the major difference is the statistic is calculated from the survey results, but the parameter requires opening all votes. So parameter is not available until until the votes are like a few days, for a few days. So a lot of estimations needs to be done up to that point. Okay, I'm going to stop here and we'll continue in the next video.